Welcome everyone. So today we're going to talk about generator motoring incidents. That doesn't sound right when you think about it, does it? Because theoretically generators shouldn't work as motors. And yet it happens more often than you think. And I hope that today, by the end of this presentation, you will not only know a lot more about this condition, this transient condition called motoring, but you will also be able to predict potential consequences of motoring incident. Would you agree that routine and overconfidence can sometimes kill? I remember well when I did my driving license as I was 18. Since then, I've been driving very well without any problems. My wife would actually say to me that I perhaps drive too confident, maybe too aggressive. And a while ago, I visited my parents. As I was the green car, let me just find a little pointer. So when I was a green car, I wanted to turn right on the roundabout, and I chose an inner line. And as I wanted to leave the roundabout, I had to cross the outer line. Unfortunately, the blue car you can see here, instead of going straight, the driver decided to make a U-turn. So basically, he wanted to do that. And because I didn't look into my mirror, I turned and the blue car hit my, causing an accident. You can imagine how scared I was as my wife and my daughter were sitting on this side of the car. Luckily, this was at slow speed and nothing very serious happened. The worst bit that I didn't mention to you is that I borrowed that car from my father-in-law. That's right, you heard it. That was my father-in-law car. And I had to call him and explain that what has happened. And you can only imagine how embarrassed I was. Why am I sharing this story with you? So a few years ago, I was lucky enough to lead a repair project of the generator that has gone through the motoring incident. The project was very challenging to the extent that I was asked to perform a presentation on one of the industry-related conferences. I thought at the time, this must be a very rare situation and we should really share this information with everybody simply to warn them. And I could have been more wrong, as since then our company was dealing with two more generators, which went through this transient condition called motoring. So it happens more often than you think. This is why we continue sharing these slides with engineers from around the world, with hope that it will help you to understand these very specific transient conditions and its consequences. And for those who don't know what we've seen on those pictures, well, that was the rotor wedge. And you're right, it shouldn't look that way. This is what the rotor wedge should look like. So this is the normal conditions. This obviously isn't. So something has happened to cause that temperature and that wedge to be bent and protruding from the rotor body, as you can see on these two pictures. And we're going to talk about it in this presentation. So what is motoring? Well, for those who don't know, we're going to go through a few slides and explain a little bit of theory, and I hope that by the end of it, you will have a good feeling of what the generator motoring is. Now, let's start with the normal conditions. So we know that the generator converts mechanical energy into electrical energy. And what we see here is the boiler that is producing the steam. Then it's a little turbine that is turning the generator rotor. Now, when you apply the DC supply excitation to the rotor, this in turn will produce the magnetic field, and then at the stator terminals, the voltage will be induced. And this is the conditions that we like. Yeah, we love it, and this is the way it should be. Let's look at the different scenario. So we know that the motor converts electrical energy into mechanical energy. So when you think about it, if you accidentally connect the generator to your national grid, in that case, you will have armature producing AC rotating flux, and that flux will induce very high currents flowing through the surface of the rotor, as you can see here. And then in time, the rotor will start turning. And this potentially could cause severe damages. And again, this is the conditions we don't like, and we want to prevent this from happening, obviously. Let's ask this question. So can synchronous generator work as an induction motor? It's usually not as simple as you might think because there's yes, but, and then on the other side, there's a big no. So let's talk about yes, but. When the machine is at full speed, so say in Europe it will be 3000 RPM, in US and some other parts of the world that would be 3600 RPM. When the machine is at full speed and for some reason if the excitation of the rotor is gone, in that moment your generator will start working as a motor. But because you should have reverse power relays, the generator should trip and nothing serious should happen to your rotor. So again, nothing to be worried about. Now let's skip to the right hand side of that slide. There's a big red no, because if your generator rotor is at standstill or it's in a bearing gear, then if you suddenly and accidentally shut down the circuit breakers connecting the generator to the grid, within seconds, and I think in about half, maybe 1 second, the currents induced on the rotor body will cause severe damages. We should really consider two different scenarios. One when the rotor is at speed and the other one when the rotor is standstill. Let's focus for a minute on the left-hand side. So when the machine is turning at full speed, you have centrifugal force acting on all the components. You have very good linkage between the retaining ring and the wedges. And in this particular example, the wedge and the retaining ring is part of the damper circuit. And because of that, you have low resistance joint between these two components. So if you have any currents flowing, they will easily go across to the retaining ring and then act as a proper damper circuit. Now, let's jump to the right-hand side and consider the situation when the rotor is at standstill or at bearing gear. In this case, there's no centrifugal force acting on these components. There is no linkage between the retaining rings and the wedges. Obviously, it's exaggeration here, but there's got to be a tiny gap between these two components. And because of that, when you have high resistance joint, any currents flowing will create that little arc. And that obviously will cause serious damages that I will show you in a minute. Let's try to answer these questions. What happens to the generator? Because we know that the generator starts operating as an induction motor. And I kind of really like this slide because what you can see on the left-hand side, you have a 3D model of the fully built generator rotor. In the middle, we removed pieces of the damper cage, and in this case, you have long aluminum wedges, and you can see that these are shorted by two retaining rings. Now, can you see the resemblance between the middle picture and the picture on the right-hand side? Yes, it looks very similar because on the right-hand side, you have cage induction motor. So this is how similar these two designs are. And as I said, generator starts operating as an induction motor. So we know, and we already said, that you will have very high currents flowing through components which haven't been designed to carry such current. Now think about it. Look at the right-hand side here, and you have a picture of the induction motor. The induction motor body is made of uh, hundreds of laminations. So if you have any currents induced, well, basically you won't have any currents induced in the rotor body, unlike the turbo generator rotor, because the turbo generator rotor is made of solid forging. So obviously, if you have any currents induced in the rotor body, they will easily flow, causing potential damages. Let's add one more thing to that equation. You might remember from your school that the starting current of the induction motor is as high as 5 to 7 times the normal full load current. That means that you have very high currents flowing through the components that haven't been designed to carry such currents, potentially causing severe damage. This is my favorite bit because what happens to the rotor? You're about to see some very good pictures from 3-generator rotors that went through the transient condition called motoring. So we mentioned that when you connect the generator accidentally to the grid, you will have currents induced on the surface of the rotor body. As you can see here, the currents will be flowing through the teeth, through the wedges, through the main poles, as well as the retaining rings. And what you can see here in the top right-hand side corner, you can see the cross-section of the generator rotor, and you can actually see the skin effect because the highest temperature is on the surface of the rotor body as well as on the wedges. And now you'll see the real stuff, the real evidence of that temperature and high currents flowing through these components. And we said that the currents will be flowing through the rotor body, as we show here. So this is evidence number one. I can prove you that this is the case. This is the generator rotor, just first example, and you can see that discoloration of the rotor surface. Normally, this surface should be shiny and beautiful, and it isn't. So this is how hot it gets when you have very high currents flowing through that surface of the main rotor pole. For those who don't know what the normal rotor pole should look like, well, it should be like this. It should be nice and shiny, as you can see on this picture. You're about to see two of my favorite photographs of the generator rotor. So we know, and it's clear, that the current is generally lazy. So instead of jumping across the air gap when you have that inertial slit, it will rather go around, as you can see on the left-hand side. Now, have a look at this. It's amazing because you can clearly see the path of the current. Instead of jumping around, it will go around the inertial slit. And you can see here and then on the bottom picture, the same location. This is the location of the highest current density. This is where it's very hot and you need to pay attention to this location when you refurbish the generator rotor like this. For those who don't remember what the rotor should be like in the normal condition, it should be nice and shiny, as you can see here on this picture. It wasn't clearly on the previous picture. I just love it so much. I hope you enjoyed these two pictures. We said that the currents will be flowing between the rotor wedges and the retaining ring. And it's true, it's actually true. I'm going to show you the evidence. Look at this, huh? So on the bottom picture, you can see the tips of the rotor wedges, and you can see that arcing damage everywhere on every single rotor wedge. And then on the top picture, you can see the damage, the arcing damage corresponding with these wedges. Obviously, the retaining rings in these conditions have to be scrubbed as well as these wedges. For those who don't know how retaining ring or brand new wedges should look like, well, have a look at this. Again, it should be shiny and nice, not as what we've seen on the previous pictures. You might be of the opinion that if the rotor has got a separate damper cage, as you can see here on these two pictures, the damage shouldn't be as severe as on the machines that don't have damper cage. Well, I don't believe that to be true, and I'm going to show you the evidence. So this is the same rotor, and you can see this location here. This is part of the damper cage and that bit that sits in the end winding. It's basically welded, this piece welded itself into the tip of the rotor wedge. Now, look at this, huh? It's interesting because these teeth here on coil 1 here and coil 1 here, you can see that it's just evaporated, yeah? Can you see it here? It's just disappeared. This is how hot it gets. And what I can tell from that evidence that you might actually have a separate damper cage as on this particular design. It won't save your machine. And this is the consequence that you might find. We said already that the current will be flowing between the wedges and the retaining wings, but also we said that the current will be flowing between the rotor body and the retaining wings. So this is just another evidence. You can clearly see a severe damage, arcing damage on the teeth. So this is the location where you would normally shrink the retaining ring when you assemble one. Yeah, so severe damage also here and there. So what happened to the wedges? We did say that the current will be flowing through the wedges, but you need to ask yourself, have these wedges been designed to carry such current? Well, not really, not really. So this is the location of one of two double airfolds. The size of that hole, and by the way, it's not a ventilation hole. It shouldn't be there. So the size of that hole is the size of my wrist. It's really, really big. And you can see that an aluminum alloy just disappeared, just evaporated. And we have another very good example of the damage that can be caused to the rotor wedges. So in this design, instead of having one long wedge going through the whole rotor body, you have shorter wedges. And because you have that discontinuity of the wedge, you can see here that the current, instead of, we already know, we said that the current is lazy. So instead of jumping across that gap, it chose to go through the rotor body and then back to that wedge. Can you see it here? Yeah. So again, pay attention to that location because this is where it got very, very, very hot. I really like this example as well. We can now have a little summary. So let's read that. So the melting points of different materials is quite high. So we have aluminium 660 centigrade, steel more than 1000, copper more than 1000, and also in our electric arc, the temperature of an electric arc is between 3000 and 20,000 centigrade. So it's quite high. Therefore, these pictures show such an extensive damage. And again, this picture shows you the temperature distribution and the skin effects when the rotor and the generator goes through the transient conditions called motoring. What else can happen? Because it's not only the rotor that will be damaged when the generator goes through these transient conditions. So over the next few slides, I will show a few more pictures with the damages not only of the components that we already seen. So this slide shows the location of the double airfoil, and unfortunately, this is the damage to the rotor body, to your forging. So this location here corresponds with that big hole that we've seen in one of the wedges. The size of my wrist, did I say that? Yeah, it's quite big. On the right hand side, you can see not as deep as this one, because this one is between 15 to 20 meters damage, but then it was around 40 centimeters long. So you also can damage the rotor body itself. And remember, this is the longest lead time item, and this is also the most expensive item. So you need to be really, really careful with that. These two pictures show damaged rotor winding. You can clearly see that distortion. Yeah, you can see distorted copper here, um, and just pieces of copper that evaporated. And again, the same happens here. So the temperature in this case must have been more than 1000 degrees for copper to melt. So one of the other consequences could be the damage to the rotor winding, not only the surface. Do you remember one of the first slides when we showed that wedge that protrudes from the rotor surface, from the rotor body? So that wedge, in this particular case, was rubbing, the surface of the stator core, causing that severe damage. So what you see here is the damage to the laminations as well as distorted uh, ventilation separators also present in a stator core. So you actually might end up damaging the stator components as well. What you can see here is my palm. It's actually the same palm. We found a lot of debris in one of the generators, and it's a conductive debris because what you see here is the piece of that wedge that was rubbing. Actually, there was more wedges rubbing the core. So we found a lot of debris in almost every ventilation duct on the back of the core, pretty much everywhere within the generator, and that will cause an extra challenges when you try to refurbish such unit. So can this be prevented? Well, it's not easy. It's as you can see on that picture, you can't dwell a big fire with a little extinguisher, especially because this particular one is half empty already. We already said that if the machine was at full speed, the reverse power relays should stop the unit, and we shouldn't have any damage to the generator. We also said that when the generator was at standstill, the situation is very different because then within seconds you will cause severe damage. Now let me read that sentence to you. So, education for power station operators to understand the consequences of transient conditions. Why did I put this sentence on a slide? So basically, when you take the three examples we just went through, the power station operators, although they knew that the generator they were running went through the motoring incident, they tried to run the machine up again and again, potentially causing even more damage than if they didn't run. So basically, they didn't understand the potential damage that a few seconds of connection of the generator with the grid could cause to the generator rotor. There's also one good news. So although the damage can be very extensive, often beyond repair, and I think you would agree with that because we've seen quite a severe damage. As far as I know, 3 of the 3 units we described are now running with no restrictions. So actually, the units we went through and we've seen today are now in the operational condition without any technical and commercial restrictions to run. I hope now you understand that sometimes impossible becomes possible, because what you see here on the left-hand side is a severely damaged rotor that went through the motoring incident. And then on the right-hand side, you can see already refurbished generator rotor forging that is ready for the winding process. So I would like to thank you for your attention. You survived, you managed to get to the very end of this presentation. I hope you enjoyed. Some of those pictures, I would say, are great, at least for me. And I hope to see you next time. Thanks again, and bye-bye.